The last thing we want to mention in this section of the course is that you can also use this approach to solve a different problem called expenditure minimization. So we're kind of used to thinking of the problem of you have a budget and you want to know how to spend it. But sometimes you'll run into a problem where you have a certain target of utility that you want to hit. So suppose you want to hit this level of utility, 100, and you know what the price is. You know, you have the price of all different goods in the economy, and we need to figure out how much income you need, how much money do you need to achieve your goal, okay? And so why would you ever need to do this? Well, it can matter when you decide how much you're going to pay people, for example, like if they get utility of 100 by not working at your job, how do you get them the same level of utility with income? Or if they're going to move to a new place, like a new country where prices are very different, how do you change the pay rate to allow them to basically get the same utility that they would have got before they moved, or else they might not agree with the move. So this thing stays fixed. All these combinations of S and F are the ones that give us 100, and we know the prices. We're not going to change those, but we're going to change the amount of income you might have. So let's suppose, here's one level of income. Here's a bit less income, but the same prices. Here's even less income, but the same prices, and so on. Okay. As we go into this corner, we have more income, and each one of these lines that I've just drawn is a budget constraint. Okay, and as you can see, we basically want to move as close to this corner where we have zero income as possible. If we want to find the smallest amount of money we need to get utility 100, well, if we give this person this level of utility up here, they can get a utility of 100 at these 2 points. Those are both affordable given that money. But we can also give them that amount of utility for less, right? If they're right at this point here. Okay, this is if we give them whatever the income is associated with this budget constraint, they can use it to buy this exact bundle, get utility of 100, and we've sort of solved the problem. If we want to give them even less money than that, then we're down here, and there's no way that we can spend that money and get a utility of 100. So whatever the income is associated with this level, that's the minimum. And, it's going to be some y divided by the price of S, or y divided by the price of food down here. Whatever that y is associated with this, that's what it's going to be. So how do we find that? Well, you can see here that, again, we have a tangency point. So we have the marginal rate of substitution equal to the price ratio. Okay, and in particular, since I've drawn S on the vertical axis, I need the marginal rate of substitution where it's the partial S over partial F has to equal the negative PF over PS. Okay, so that's my first equation. And then my second equation is I need to have utility equal to 100. So I'm going to have some utility function of F and S, and it has to equal whatever my utility target is, in this case 100. Okay, and this is 2 equations and 2 unknowns as well. Draw a little 2 here. And so we have enough information to solve the problem. It's just unlike the sort of normal case where you use the budget constraint to figure out as your sort of second equation. Here you use the utility function as your second equation. But hey, you can still do it.